Hi, I'm Josh Hooks. I'm a solution architect at Software AG, and I'm here to show you an example using Cumulocity IoT of how we can pull in measurements in real time and then calculate lower and upper control limits to dynamically generate alarms and dashboards that we can use within Cumulocity or your external applications or through emails or texts. So to start with, I'm going to be here in my Cumulocity tenant, and specifically in the cockpit application that we use for building dashboards and other visualizations. And the data that you're seeing here is actually coming from my phone. So as I move it around, you can see things change. And if I go into some of these graphs, you'll see that's the compass data, the acceleration data, and then this graph is just using the X acceleration that we'll use for this example with lower and upper control limits. These values are all just coming from a sensor app that you can get on the App Store or Google Play and try out yourself as well. So we have the values coming in. Let's switch over to streaming analytics where we can start building out these calculations. And we'll do everything from scratch. So within the analytics builder in streaming analytics, I have a number of models created here, but I'll create a new one to start out. And this one we'll just call LCL/UCL. And looking at the canvas on the left side here, we're going to pull in my phone as an input. So just drag that into the canvas. And then what I'm looking for is that measurement input of acceleration X. So I'm just going to select that from the drop down here. Every time that this X acceleration gets sent to Cumulocity from my phone, it will trigger this model. And to calculate LCL and UCL, there are two main things I need, which is the average and the standard deviation. So to do that, we're going to look at the aggregate functions here and then pull in average and pull in standard deviation. And for these, you get a window size as well. So how long it's going to keep the values to calculate against each other. In this case, I'm just going to do 5 seconds for both to make it very quick to react to changes for this example. And then pull in the output value to the input value of each of these blocks. So now each time it comes in, it'll also generate that average and standard deviation for that window size. And in this case, I'm ready to push it into that formula that gives me LCL and UCL. So for that, I'll go into my calculation blocks and pull over expression. And in this case, I want an expression that looks like input 1, which will be the average plus 3 times the standard deviation, which will be input 2. And then this I will copy and paste, pull down here for the lower control limit, which will just be minus instead of plus. And so average goes into input 1 of this block and input 1 of this block. Standard deviation goes into input 2 here and input 2 here. And so those will correspond to the input 1 and 2 within the formula. And so now I'm calculating those lower and upper control limits in real time, and I want to send that back to the device. So now I'll go to my outputs, pull in the phone just like I did for my inputs, and have my measurement output be a measurement that's calculated from the lower and upper control limits. And I am going to do this twice. So I'll call this control limit, copy this, and UCL. And then for the bottom one, same thing, control limit and LCL. And then when I push this into the value of each of these, it will create that new upper and lower control limits as values on the phone as well. So then I can display those. So when I go back to my models, I'll switch this to production so I can activate it. So I'll have it run in real time. And I'll switch back to cockpit quickly so I can display it on this graph as well. So then when I click the cogwheel here and edit this widget, I can add in these control limit values for LCL and UCL, save it, and they'll start appearing on the graph. It's very close to 0, so you see basically no difference. But as I move my phone around, you'll see it dynamically start to generate these bands in the top and bottom that represent those control limits. And the blue line represents the actual acceleration X value that we're seeing. So as I move left and right, it's kind of expected. It stays within the bands. But then if I start to shake my phone aggressively, you'll see that jump outside of the band, and then the band try to respond as well. And then it will settle as I let my phone sit down as well. So crossing the UCL and LCL is important, and I want to be alerted about that as fast as possible. So for that, we're switching back to Streaming Analytics, going to Analytics Builder, and building out a new model that will be similar to the old one. So we'll just call this LCL UCL threshold. And then for this, we're bringing in our phone the same way we did in the last model. But in this case, we're looking at 3 values specifically. So we want to see acceleration X. We'll copy and paste this. We want to see LCL, and then we want to see UCL. And so in this case, I want to use the expression block the same way we did last time and use this twice. So the top one will be my UCL calculation. So we'll put the acceleration into input 1 of both of these, and then LCL will become input 1, input 2 in the bottom, UCL input 2 in the top. And so in this case, I'm looking for anytime my acceleration is above the UCL, and then anytime the acceleration is below the UCL or the LCL. And then for this, we'll output an alarm instead of doing a measurement this time. So we'll bring the phone in as an output. We'll generate an alarm. And then we'll say this is the alarm type is UCL threshold. Add in that's the message as well. Copy and paste this. And then do the same for LCL. So this will be an alarm, and then I need to set the severity as well. So severity, we'll just do major for now. And then connect each of these up to be the create alarm trigger. So that will happen in real time now. So let's save that. And go production, activate. Clear my current alarms. And let's set up my alarm list to also include the LCL threshold because I already have the UCL threshold set up. So LCL threshold and UCL threshold, clear this again. And so you'll see as I move my phone around, UCL threshold will trigger quickly as I kind of get the band set up. But then as it is set up and then I shake my phone aggressively, you'll see LCL threshold trigger. And then you might see UCL threshold trigger again if I let things die down and then shake my phone again. So the idea being that you're seeing anytime something out of the norm happens with the movement of a device or an asset out in the field. And we can trigger on that dynamically and in real time. So hope you enjoyed this quick streaming analytics example that we can also display and act on in real time.